Hey, hello there. So for today's binary search question, I'm looking at classic 174 searching a 2D matrix. We have a m by n matrix which has the following properties. Each row is sorted and the first number of each row is larger than the last number of the previous row. As example, 1357, this row is sorted by itself. When we look at the next row, it starts with the number 10, which is larger than 7, and that row by itself is sorted, which ends at with a number 20. We look at the next row, it starts with 23, which is larger than 20. So that's a matrix that satisfies this property. So based on this property, if we can apply a flatten operation to flatten the last axis, it will be equivalent to just concatenating all those rows together to form a single vector. It will be a sorted sequence 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 50. Once we get that sorted sequence, we can apply binary search to efficiently find any element that we want in this find a target value inside this flattened vector. But the problem with that is we have to sort of like create a physical copy of the whole matrix. If there are methods that can just give us the view, vector kind of flattened view of this original matrix without using extra space, then it will be a viable solution. But if that's not an option, we're gonna be modify the binary search algorithm to work on this special kind of matrix. The only change that's probably needed is just how the upper bound, lower bound, and the random pivot number translates to the row number and column number. So the lower bound is going to be 0, which is row 0, column 0. The maximum, the upper bound is going to be number of row multiplied by number of column and subtracted by 1, which represents the number of row subtracted by 1, that many rows, and number of columns subtracted by 1. That's the upper bound. And we don't need to be super tight. It doesn't really waste a lot of time if we got a relatively loose but safer upper bound. And just the important part is the arbitrary kind of middle point that will be taken inside this during the binary search. We're gonna do a div mod operation with the number of columns to figure out the row number and column number, and use that to grab an element and do the comparison. So yeah, that's pretty much the reasoning about this problem. It's going to be taking log of m multiplied by n in time, and the space is going to be constant. So yeah, let's just grab the number of rows, number of columns, then we're going to initialize the lower bound to be 0, upper bound to be just be a little bit loose to be safer, to be this. Initialize some variables, the middle value, the row number, the column number, and then we're going to apply the binary search. So to find one value, we want to be able to exit this while loop, so that's why we have an equal sign here. We're gonna first calculate this median pivot number, which is this. Then translate this middle number into the actual row and column. So this is the div mod with the number of columns to get to the row index and column index. Then we can do the comparison. If we find the number, we can return true. Otherwise, we would check are we on the upper side or are we on the smaller side, and based on that we can update the lower bound and upper bound. If we are strictly larger than the target, we can lower our upper bound. Otherwise, we will increase our lower bound. And after that, we should return false. That means the binary search failed to find the target value inside this matrix. Since this question is quite old, as a safeguard, we should try to. Oh, sorry, why there is a star there? Try to do a little bit safeguard to the program. And that, I think, is the code. Just modify the binary search, change the lower bound and upper bound to be the zeros element and the bottom right. And then when we get in the middle point, we need to do this transformation to calculate the, translate that this 1D number into the 2D cell location. And then everything else is pretty much the standard binary search. Oh, no. What's happening? Address sanitizer, heap buffer overflow on address. What's going on? Oh, okay. I should make it a little bit tighter. So if we have one row, one column, this will be 1 multiplied by 1, and if we don't subtract by 1, we will potentially go to there, which is problematic. Okay, let's subtract by 1. Okay. All right. I'll think about this in more detail. Is this tight enough? If I put this to 2, it will be. I think it will be a problem, right? If we have just one cell, yeah, subtract by 1. Yeah, that's the correct upper bound, I think. All right, so that's for the question.